Crypto mixers and tumblers are privacy-enhancing tools designed to obscure transaction trails on public blockchains. Public blockchains record all transactions, creating a visible trail that connects sending and receiving addresses. They work by pooling together multiple users' cryptocurrencies and then redistributing them, making it difficult to trace the original source of funds. These services essentially mix or tumble coins from various sources, breaking the on-chain connection between sending and receiving addresses. While the terms mixer and tumbler are often used interchangeably, they both serve the same fundamental purpose of increasing transaction privacy. These privacy tools have several key characteristics. They break on-chain connections between addresses, pool funds from multiple users, and ultimately enhance privacy on public blockchain networks. The crypto mixing process involves three main steps that work together to obscure the transaction trail. First, users send their cryptocurrency to the mixing service. Second, the service combines these funds with cryptocurrencies from other users in a large pool. Finally, the service returns different coins of equivalent value to new addresses provided by the users. Let's visualize how this works. First, multiple users send their cryptocurrency to the mixing service. Inside the mixing service, all funds are combined into a large common pool, making it difficult to trace which input connects to which output. Users provide the service with new addresses where they want to receive their mixed coins. The mixing service then returns different coins of equivalent value to these new addresses. The timing of returns is randomized, and amounts can be split into multiple transactions. This process effectively creates a break in the transaction chain that appears on the blockchain. This break in the chain makes it significantly more difficult for blockchain analysis tools to track funds or connect the original sender with the final recipient. Several mixing technologies exist in the cryptocurrency ecosystem, each with unique approaches to enhancing privacy. Let's explore 5 major types of mixing technologies used to enhance cryptocurrency privacy. Centralized mixers are the simplest form, operated by a single entity that controls the entire mixing process. Users send their coins to a central service, which mixes them with other users' funds and returns different coins of equal value, minus a fee. This requires trusting the service, which knows the connection between inputs and outputs. CoinJoin protocols enable multiple users to collaboratively create a single transaction with multiple inputs and outputs without requiring a central coordinator. This peer-to-peer approach breaks the direct link between specific inputs and outputs, enhancing privacy while allowing users to maintain control of their private keys. Zero-knowledge proof systems like zk-SNARKs allow users to prove they own funds without revealing which specific funds they own. This cryptographic mechanism enables one party to prove a statement is true without revealing any additional information. It's used in privacy-focused cryptocurrencies, like Zcash, to enhance transaction privacy. Atomic swaps enable the exchange of cryptocurrencies across different blockchains, enhancing privacy by breaking the transaction trail. These swaps use hash time-locked contracts to ensure transactions either complete fully or not at all, eliminating the need for intermediaries and reducing trust requirements. Layer 2 privacy solutions handle transactions off the main blockchain before settling them, reducing the on-chain footprint and making transaction tracking more difficult. These include technologies like the Lightning Network, sidechains, and state channels. They batch many transactions into a single settlement on the main chain, combining privacy benefits with improved scalability and reduced fees. Let's compare these 5 mixing technologies based on their privacy level, decentralization, and complexity. Each technology offers unique trade-offs between privacy, security, and ease of use. The choice depends on specific privacy requirements and technical constraints. Now that we understand the different types of mixing technologies, let's explore their legal status and regulatory concerns. Crypto mixers have gained notoriety for their use in various criminal activities. Ransomware operators frequently use mixers to launder extortion payments. After locking victims' files and demanding cryptocurrency payments, these criminals route the funds through mixers to hide the money trail. Darknet market vendors employ mixing services to obscure the source of their cryptocurrency earnings. This makes it difficult to connect illegal sales to identifiable wallet addresses. Hackers who steal from cryptocurrency exchanges often attempt to launder funds through mixers. By doing so, they aim to evade detection and make stolen cryptocurrency usable. According to Chainalysis, approximately 10% of all funds sent to mixers come from illicit addresses. This percentage varies significantly between different mixing services, with some having much higher rates of illicit funds. This association with criminal activity has drawn significant attention from law enforcement agencies worldwide. International efforts to monitor and regulate mixing services have increased as authorities try to combat cryptocurrency-facilitated crime. Several mixing services have gained prominence in the cryptocurrency ecosystem, each offering unique approaches to transaction privacy. Let's explore the most popular mixing services and protocols used for enhancing privacy in cryptocurrency transactions. Tornado Cash was one of the most widely used Ethereum mixers before being sanctioned. It's a non-custodial privacy tool that uses zero-knowledge proofs to break the on-chain link between deposit and withdrawal addresses. Users deposit fixed amounts of ETH or ERC20 tokens into a smart contract, which can later be withdrawn to a different address. For Bitcoin, several wallets implement the CoinJoin protocol to enhance privacy. These services coordinate transactions between multiple users to obfuscate the links between sending and receiving addresses. Wasabi Wallet is an open-source Bitcoin wallet that implements the Wabi-Sabi CoinJoin protocol. It uses a central coordinator, but in a trust-minimized way. Users need a minimum amount of Bitcoin to participate in mixing rounds. Samurai Wallet is a privacy-focused mobile Bitcoin wallet that emphasizes user sovereignty. It incorporates the Whirlpool CoinJoin implementation and offers additional post-mix spending tools to maintain privacy after mixing. Whirlpool is a CoinJoin implementation focused on Bitcoin that uses fixed denomination mixes for enhanced privacy. It's primarily integrated with Samurai Wallet and designed to break deterministic links between inputs and outputs. The CoinJoin process works by combining multiple Bitcoin transactions into a single transaction, making it difficult to determine which inputs correspond to which outputs. This significantly enhances the privacy of Bitcoin transactions. Some cryptocurrencies integrate privacy features directly into their protocols, providing built-in transaction privacy without requiring external mixing services. Zcash is a privacy-focused cryptocurrency that uses zero-knowledge proofs called ZK snarks to shield transaction information. It offers both transparent and private transactions, giving users the flexibility to choose their privacy level and selectively disclose information for compliance purposes. Monero implements privacy by default through multiple mechanisms. Ring signatures obscure the source of funds by mixing a transaction with others. Stealth addresses create one-time destinations for each transaction, and Ring CT conceals transaction amounts, creating a comprehensive privacy solution. Let's compare these different privacy solutions based on their key features and security properties. Each service offers different trade-offs between privacy, usability, and regulatory compliance. Tornado Cash provides strong Ethereum privacy but faces sanctions. Bitcoin CoinJoin implementations like Wasabi and Samurai continue to operate with varying degrees of usability. Privacy coins offer the most seamless experience but may face restrictions in some jurisdictions. The cryptocurrency privacy landscape continues to evolve as new technologies emerge and regulatory pressures shape the ecosystem. From the initial CoinJoin proposal in 2014 to the launch of privacy coins like Zcash in 2016, advanced Bitcoin mixing wallets in 2018, and DeFi privacy protocols in 2020, the space has continuously innovated. However, 2022 saw increased regulatory scrutiny and sanctions against some privacy tools. Looking forward, we can expect continued innovation in privacy technologies with a focus on balancing strong privacy guarantees with regulatory compliance. Cross-chain privacy solutions and Layer 2 privacy mechanisms are likely to gain prominence as the ecosystem adapts to evolving challenges. Crypto mixers face several technical challenges and vulnerabilities that can compromise user privacy. 5 major vulnerabilities affect crypto mixers: timing analysis, volume analysis, hacks and exit scams, centralization issues, and advancing blockchain analysis techniques. Timing analysis can potentially link inputs and outputs if users withdraw funds immediately after depositing. Blockchain analysts can identify patterns where deposit and withdrawal times are suspiciously close, creating a correlation between seemingly unrelated addresses. Volume analysis may reveal connections when unique or large amounts are processed through a mixer. A highly specific amount, like 2.7532 Bitcoin, is easily traceable, as it stands out among common denominations, making it simple to connect the input and output wallets. Some mixers have been compromised by hacks or exit scams, resulting in user fund losses. Security breaches can lead to the theft of all pooled funds, while dishonest operators may simply disappear with user deposits in what are known as exit scams. Centralized mixers introduce trust issues, as operators could potentially keep records of transactions or be compelled to share information with authorities. This creates a fundamental contradiction. Users seeking privacy must trust a third party with their sensitive transaction data, undermining the very purpose of using a mixer. Advanced blockchain analysis techniques continue to evolve, potentially reducing the effectiveness of simpler mixing approaches over time. From basic address clustering and early blockchain analysis to today's machine learning algorithms, the tools available to de-anonymize transactions grow more sophisticated each year. As quantum computing and artificial intelligence advance, even today's most secure mixing protocols may become vulnerable to future de-anonymization techniques. To summarize, crypto mixers face multiple technical limitations that can potentially compromise user privacy and security. Understanding these vulnerabilities is crucial for users seeking privacy solutions and for developers working to create more resilient mixing protocols. The future of cryptocurrency privacy tools is likely to involve several significant developments. We'll see increased integration of privacy features directly into blockchain protocols rather than as separate services. Layer 2 privacy solutions will continue to evolve, offering both scalability and enhanced privacy features. Regulatory frameworks specifically addressing privacy tools will likely emerge in many jurisdictions, with different approaches around the world. Cross-chain privacy solutions will become more important as the crypto ecosystem becomes increasingly interconnected. The tension between privacy advocates and regulators will continue to shape this landscape. This tension may lead to privacy tools that incorporate regulatory compliance features while still protecting user privacy. To summarize, the future of cryptocurrency privacy tools will likely include built-in protocol privacy, advanced Layer 2 solutions, diverse regulatory frameworks, cross-chain interoperability, and privacy tools with compliance features. The evolution of privacy in blockchain will ultimately be a delicate balance between innovation and responsibility.